BIGFile, Bayesian Information Gain for fast file retrieval. Navigating a hierarchical file system is a very common task. Yet retrieving a particular file can be cumbersome and repetitive, especially for deep hierarchies. How can we improve the efficiency of hierarchical file retrieval? We introduce BIGFile, a fast new file retrieval technique based on the Bayesian Information Gain framework. BIGFile offers interface shortcuts that help users navigate to their desired file or folder. BIGFile features a split adaptive interface. The static area presents folders and files using a traditional list view. The adaptive area presents shortcuts to help users navigate to their intended file or folder. After each user input, the adaptive and static areas are both updated. If the user clicks on the Animal folder, the static area shows the subfolders inside Animal, and the adaptive area shows the proposed shortcuts. We use the Bayesian Information Gain framework to find these shortcuts. The computer tries to gain information from the user to determine what she wants. The random variable theta models which files or folders the user is potentially interested in. For each potential target theta, the probability p of theta models the system's prior knowledge of the user's interest, as indicated by the use history of how recently and how frequently the particular file is retrieved. The random variable x models the maximally informative view the system generates each time, representing the system feedback. The random variable y models the user input, revealing what she wants. This user input is then taken into account, and the system updates its knowledge about the user's interest. We present two algorithms to look for the maximally informative view x equals x. The optimal algorithm BIGFile opt works as follows. Let us assume a 5-level perfect binary tree. Users are only interested in files located at the bottom level. The user begins by clicking on the root folder. The subfolders then appear in the static area. We conduct an exhaustive search to find a combination of two nodes. We find that these two, plus the two folders in the static area, maximize the expected information gain. BIGFile opt finds the optimal set of shortcuts. Unfortunately, the computational cost is too high. We thus introduce BIGFile Fast, an efficient suboptimal algorithm that returns results in interactive time. First, since the system has some prior knowledge about the user's interest, as represented in the initial probability distribution of the potential targets, we choose n, here 5, most probable potential targets. Next, we find their parents up to the root. Then, starting from the bottom, we recursively replace the nodes that have a single child with that child. We now have a new search set where we look for a combination of the two. We can further reduce searching by effectively pruning branches using mutual information's characteristics. If the expected information gain of purple and red is greater than the expected information gain of blue and red, where blue is the child of purple, we can prune the blue branch and move directly to the green branch. BIGFile Fast dramatically reduces search time, making it real-time, and selects sets of targets with near-optimal expected information gain. Inspired by our pilot study with real users, BIGFile also provides relative paths to the estimated items to provide contextual information. Estimated shortcuts found by BIGFile Fast and relative paths to them. All are accessible. Here are several examples. Here, the user has direct access to a target at level 3 and at level 6. Here, the target is not in the shortcuts, but an intermediate folder is. The user clicks it, and the new set of shortcuts includes the target. We conducted an experiment to compare the performance of BIGFile, ARFile, the AccessRank prediction algorithm instantiated with a split interface, and a finder-like list view. In terms of task completion time, BIGFile is significantly faster than ARFile, which is significantly faster than Finder. Moreover, the deeper the target is located, the better BIGFile performs compared to ARFile.